I'm Davide Sanalitro from STMicroelectronics. My colleague Edoardo Bollea and I would like to share with you our in-depth case study on optimizing register map verification methodology. Every digital device has a control and status register described by a register map. The CSR serves as the memory that stores the information and configuration the system on chip wants the peripheral to have. The digital verification engineer must verify the register map to ensure the data is always written to and read from the proper places. The CSR are fundamental to the correct operation of any function in an integrated circuit. For this reason, there is a strong need to guarantee the absence of malfunction inside the CSRs. Our team at STMicroelectronics uses an AMBA high-speed bus. But in the test case under analysis, don't have an AHP peripheral, but a custom communication protocol. To achieve an optimal register map verification methodology, we explored the state-of-art methodology to verify CSR's behavior exhaustively. We used the two register map already verified with UVM using Cadence Xcelium. We then run formal verification using Jasper CSR. Our main objective was to compare how formal performance and result different from the UVM approach. And we compared the result in terms of time to set up the digital verification environment, time to find a bug, time to debug a failure, in terms of number of bugs found, and in terms of coverage reached, both functional and code coverage. Let's compare the digital verification environment between UVM and Jasper CSR formal. STMicroelectronics UVM environment uses Cadence Xcelium for dynamic simulation. UVM let us verify the register map from top level, including the serial protocol and the integration of the CSR with the rest of the device. It takes about 2 weeks to first build an environment that stimulates the device correctly. We must build many verification objects to start the register map verification using UVM, because we need to build a UVM test, a UVM environment, a UVM agent, including a driver and monitor to send transaction to the device and the test and sample the data from the dudes. We need to build the UVM register adapter, UVM register block, UVM register classes, and UVM register callback. We must also write an entire class for each register. It means if we have 100 registers, we must write 100 classes. And additionally, the test bench is written manually by a verification engineer. It means the quality of the result depends on the test bench quality. Instead, with Jasper CSR, use a formal verification approach. It compiles the RTL and transforms it into a mathematical model of explorable states. And Jasper formal engine know how to reach any state. The Jasper CSR formal has a lot of automation. Our verification engineer don't need to write a session, so they don't need any formal or system Verilog expertise. We brought the CSR attributes in only 1 day, so it was much faster to set up than UVM. We only had 3 steps with Jasper CSR. The first one is write the CSR attributes based on design specification. We can write the CSR attribute in a CSV or EP-exact format. The attributes include the register address, the reset value, the number of bits for each address, and the type of access. For example, read and write, read only, read clear, any type of access. We use the CSV format because it's easier. The name makes it clear what the attribute does. The CSV is also very compact. Each register only needs a few lines of description. The P-exact standard could be useful for engineers who expect the CSR attributes to be reused by another team. The second step is connect the Jasper bus adapter to the device under test. And Jasper then automatically generates the proof and exhaustively prove all the property written in the CSV file. And if a failure exists, Jasper automatically creates a counterexample for us. Therefore, the debug time is 0. When an assertion for an attribute passes, it means any simulation we try to run in dynamic simulation using UVM will also definitely pass. It's not possible for an attribute to pass with Jasper CSR and fail with UVM. The third step is create a tickle script for Jasper CSR to compile the design and the CSV consistently. In summary, creating a UVM environment takes about 2 weeks, as we must build many verification objects, and additionally, the result depends on the quality of the verification engineer's manually written test bench. Instead, for Jasper CSR, we only needed to write the CSR attribute in CSV, and the results were sufficient for an exhaustive verification, register map verification. We used Jasper CSR formal verification app on 2 register maps already verified using UVM. In the first case, in addition to the register map, there was sequential logic at the input pin of the register map and combinational logic at the register outputs. Because Jasper CSR formal app cannot verify portion of the RTL that is not part of the control status register, that portion was uncovered. The second case contained only the control status register, and this is the most representative use case for Jasper.
Hi, this is Edoardo Bollea. Let's now look at our results for each case, starting with case 1. The first metric we focused on was code coverage, which measures how many lines, expressions, and net toggling of the RTL were stimulated during simulation or during formal verification. For case 1, UVM dynamic simulation with Xcelium had a high coverage of 99%. Jasper CSR's code coverage was lower because the register map also contained elements that were not actual registers, such as synchronizers and combinational logic, that Jasper CSR does not verify. It's important to emphasize here that when we combine the coverage results from UVM and Jasper CSR, we can still increase our total coverage, which means that Jasper was able to stimulate and reach some of the registers that were not stimulated by dynamic simulation. In the second case, Jasper stimulated everything, all case scenarios, while UVM stimulated a bit less than Jasper. The particularly important result is that by combining both methodologies, we were able to achieve 100% of code coverage for the register map. This means that every line of code, every possible combination of signals inside of the register map was covered. Our second metric is functional coverage, which measures how much of the functionalities described in the specification is coherent with the implementation. If the specification says that something should happen at a given moment, functional coverage tells you if it actually did. With UVM, this is usually measured through 2 parameters. The first one is the number of tests passing. In this case, we have 0% of passing tests. Each UVM test returned at least 1 failure. Either our specification was wrong or we didn't know where the problem was in the RTL, which would lead to an unknown debugging time. The second metric is cover groups. Cover groups sample the signals inside of the design that we want to collect at a given moment. In this way, we can determine if we've reached all the possible signals value for those signals during simulation. Even though we hit 95% of cover groups, which is important, increasing this percentage after a certain point becomes extremely hard because you either need to increase the number of tests or you have to change the randomization. For instance, we run one random test 100 times with different seeds for a total of 150,000 random accesses to the register map. So even though we had 95% of cover groups covered and 0% of tests passing, we do not know which part of the RTL are not working. That's where we had to go look for the problems. On the other hand, Jasper CSR has only one functional coverage metric, that is the number of assertions passing. Jasper automatically generates assertions for all the attributes described for the register, and about 70% of those assertions were passing. So with Jasper, we know that 70% of the register map is working and will always work as expected. Plus, we know exactly which 30% of our registers were not working according to the specification. And this is a very good result. Regarding why 30% of the assertions failed, we didn't know whether if the specification or the implementation was wrong, so we let the assertions fail. The second case, we had a better specification. More UVM tests passed, but the cover groups were a bit lower to 88%. We ran the same amount of tests with basically the same randomization. And again, if we wanted to increase our numbers, we would need to change the randomization or increase the number of tests. Instead, Jasper has 98% of assertions passing, meaning that all the registers were working as expected and everything was good. Probably the most important thing we want to emphasize is the time savings with Jasper CSR, as engineers are always out of time. The first big difference, as Davide mentioned earlier, is the setup time. UVM takes nearly 2 weeks to set up, as you must build many verification objects, while CSR only took us 1 day to set up, write all the Jasper attributes in CSV, and the TCL file to run everything. So as soon as we gave Jasper the inputs, it immediately started generating the assertion and started finding bugs. So the time that is required to find the initial bug is basically zero, probably less than half a day. And as you can see from the chart, UVM took much longer to find the same number of bugs when compared with Jasper. But even though Jasper CSR is faster in finding bugs, we must still combine the two methodologies. UVM can also find bugs related to how the register map interacts with the other parts of the design, something that Jasper CSR does not cover. For example, UVM can detect problems related to the timing of the register map with respect to other blocks, or if a synchronizer that writes to the register map is not working, or problems related to the interconnection of the map with other blocks. Furthermore, not all the bugs that Jasper CSR found were also found by UVM. So the combination of the two methodologies is able to find all possible bugs. The last time comparison to make is about the total runtime. We used Cadence vManager verification management tool for our UVM methodology with Xcelium and for Jasper CSR. Regarding the single test, Jasper CSR's verification time is much faster. This is because with UVM dynamic simulation, even a single test must simulate thousands of random accesses for the entire design. And it takes up to 10 times longer than a single Jasper run. This is because Jasper only needs to transform the register map into the mathematical model, and the register map is a single small block. Again, with the test regression, UVM takes even more time, up to 15 times longer, as you must launch the single test hundreds of times. While for Jasper, you still need to launch your single test to stimulate all possible scenarios. In the next two slides, there are two examples of bugs that we were not able to find with UVM, but the Jasper was able to find. The first one is a bit that by specification was a read-write bit, was also an auto-clear bit, meaning that if A was written to 1, after some time, a signal A reset would clear the value of A. At the same time, A is also locked by signal L, meaning that if L is 1, A cannot be written. The bug that Jasper was able to find was that if the lock condition occurred before the auto-clear signal arrived, the reading operation to bit A would still be 1, meaning that the auto-clear didn't have effect on the bit. This is something very hard to find with UVM due to the strict narrow time window in which the events must happen. The second bug is related to a bit B that was a read-write bit that should only be reset by the power-on reset and POR. What Jasper was able to find was that an external fault was able to reset the field. So even if the NBPR was stable, we were able to read B equal to 0 after writing it to 1. This bug might potentially have been found with UVM, but to do so, we would first need not only to describe the register map and the serial interface, but also to describe the fault behavior in UVM and stimulate the faults, which would require even more time. Jasper instead found this bug right away. An important thing to point out here is that UVM cover the RTL portions that contain those two bugs. And even so, our random regressions never stress those sequences under analysis, and some bugs were missed. In contrast, Jasper was able exhaustively to find all the bugs and generate counterexamples nearly instantly, so that we were able to understand why things were not working as expected. The conclusion from our activity is that combining both Jasper CSR and UVM as a register map verification methodology improves all three of our metrics. We maximize our coverage, we find more bugs, and we get results faster. Since we completed this study, we have already successfully used this new methodology combining both approaches for recent designs. Our first step is to create the CSR attributes in CSV and run Jasper. This is the fastest way to detect any bugs due to the faster setup and runtime. Additionally, in some cases, this is the only way to detect certain bugs. Examples of this kind of bugs are access type bugs, incorrect values, locking condition, dependencies between registers, and so on. Because we found those bugs sooner with Jasper CSR, we were able to correct them sooner. So we had fewer bugs to find when we run UVM, which is our second step. UVM is still a necessary element, as it is the only way to detect potential bugs caused by the incorrect integration of the register map within the rest of the design, and it's also the only way to know if the serial protocol is correctly described by the designer. When we use this new two-step register map verification methodology in our latest design, we actually find all the bugs related to the register maps with Jasper CSR. So when we build the UVM environment and run our regressions, the only additional bugs we found were related to the serial protocol. Everything else was already done by Jasper, and this saved a lot of effort. So for a metric-driven verification flow, only the combination of the methodologies allows us to save time, completely verify the register map, and reach the maximum coverage. Thank you.